Okay guys, glad you're back. This is inverses of functions. This is for Math 3. First thing we talk about is that one way you can find the inverse relation is by switching the x and the y. Switching the x and the y is what we're going to end up doing. So I've given you two different relations here, one in set formation and one is tables. So we're going to look here. I'm just going to switch all the x's and y's. So you can tell right here, instead of 1, 5, I'm going to switch it to 5, 1. I just switch them. It's that simple. Do the same thing for the others. Okay? So the inverse of set A is taking all of the x's and switching them with the y's, and vice versa. Let's try the table, same idea. Okay? So as you can see right there, I'm just going to take 0, 5 and switch it, make it 5, 0. Now, this doesn't actually change, but I did switch them. Okay. Now the next thing I want you to recognize here is I highlighted this. This is the way you write the inverse. Okay. This is the way you're going to most commonly see it written. And what this means, if you have f to the negative 1 power and in front of the x, that's telling you to do the inverse of f of x. It's not telling you to raise it to the negative 1 power. It's a shortcut notation that means the inverse. So it'll either use the word inverse or it'll use this notation here, so you need to be familiar with that notation. Now we're going to graph all these relations, so I'm going to graph all of set A, and then I'm going to graph set B. And I want you to notice that it's kind of hard to see anything that's going on. So you don't really notice a pattern there. So what I'm going to do instead is, because set A is just 3 points make a triangle, so I'm going to come down here and I'm going to make that a triangle. And the same thing with B. Excuse me a minute. Alright, sorry about that. But as you can see, if I make the red into a triangle and the blue into a triangle, it's a little easier to see that there is something going on here. Okay, and it is a reflection. If you'll turn your paper sideways, you'll see that this is a perfect mirror image of each other if this is the center line, the y equals x line. Okay? I'm going to try the same thing over here and see what happens. First, I'll just graph my points and go ahead and connect them. I'm going to graph the inverse points and go ahead and connect them. And I hope that you notice once again that I do have a perfect reflection. It's a mirror image. Okay? And that's what we find out, is we find out that the graph of a function and its inverse are reflected over the line y equals x. Super important. Okay, super important. Take a minute to chew on that for a while. Okay, now we're going to take a minute to check out the domain of set A and just set A right here. So I've gotten rid of the graph, but I write down the domain and the range of set A. Okay, set A was up here, so it's from our notes. Now I'm going to write down the domain and range of the inverse, which I don't have here anymore, but remember we just wrote that down, so I'm going to look at the inverse of it. And here's what ends up happening, of course, is you see that, look, the domain of set A is the same thing as the range of the inverse. And the range of the inverse set A is the same as the domain of the inverse. And that's, of course, what we're going to write down. Alright, now we're going to find the inverse of a function. Now, a function is a relation, so if you look at the top of the page, we already know that we can switch the x and the y. And guess what? That is what we're going to do. We're going to switch the x and the y. Alright? But we're actually going to do two steps here. After we switch the x and the y, we're going to solve for y equals. So we're going to come down here and check this out. Alright, first thing I did, I want you to recognize, is I didn't have a y, so f of x is equal to y, so I just rewrote it. And now I'm going to look for the inverse function. So to find the inverse, I switch the x and the y. Notice I just literally took the x and y out and switched them. Now I do step 2 and I solve. Okay, so in the box here, y equals x plus 5 over 2 is the inverse of 2x minus 5. Now, use whatever method you choose in order to graph this. You can use your calculator or whatever, but I'm going to graph the blue function. Blue function is that line. I'm going to graph the purple function. Ends up being that line, and I hope you recognize that it is a reflection over the line y equals x. We'll try this one the same way. This is a little trickier to solve, but I'm going to try it the same way. Okay, I just started off rewriting it, so I had the y equals. And now I'm going to find the inverse of the function by switching the x and the y. Okay, so I'll take a minute, just notice I switched the x and the y. Now I'm going to solve. Okay, we'll get rid of the 1 on both sides. And now we remember that the inverse of a square is the square root. So I'm actually going to take the square root of both sides. And also remember, if you introduce the square root to a problem, you have to do plus and minus that square root. Ends up looking like this. Of course, you're going to notice that to get the y by itself, you're just going to subtract 3 from both sides. And you end up with this. Now, I do have a plus or a minus here, so I'm going to have to take care of this. First, I'll graph my quadratic. Okay, and all I did was use my transformation rules. You can plug it in your calculator if you choose and check out the table. Now I'm going to graph the inverse function. Now, this is actually two functions. It's the positive square root function and it's the negative square root function. So there's the positive square root function. Here's the negative square root function. And I hope you recognize that it's a reflection. All right. Got any questions? Let me know.